Telecommunications is a highly competitive global market. Among the activities setting telcos apart is customer service. To ensure its quality, companies must use monitoring tools that enable them to detect network problems in real time. The following demonstration shows how ILOG and IONA software components can be used to develop such tools and make them available through the web. Let's begin by explaining the architecture of our demo system. Here, we have an application server based on ILOG components communicating with different client applications through CORBA-compliant IONA middleware. The application server models the network elements together with their alarms. In the model, we first encounter the root, which is made of interconnected sites. Each site is made of elements, and each element of cards. Connected to this server are several client applications written in C++. They display business-specific graphical user interfaces. IONA Orbix is now implementing the Internet Inter-Orb protocol, which allows Java client applications to connect to the server through the Internet. Now, with these two machines, we are going to run the application server and the graphical client applications. We'll launch the demonstration by starting different programs on the machines. The first process is web server, which makes the server accessible through a web address. The second process is Orbix daemon. It manages all the CORBA connections between the server and the client and implements a security protocol. The third process is the application server. It will fill its object model with network element data from management information. On the client machine, we are going to launch a client application that will connect to the server. This client application is graphical. It will display our network, modeling it in the server. We can zoom in on the map, scan it, and open a second window to view the background map. ILOG Views also allows graphical navigation. By double-clicking, we can bring up another panel with a background bitmap overlaid with a network. This network is made up of network elements and links between them. By double-clicking on an element, we can show the shelf associated with it. ILOG TGO is the add-on to ILOG Views that provides the standard elements for visualizing a network management system. We have several types of predefined elements. We have the automatic drawing of element links. We also have the ability to display the states on each network element. And finally, we have a way to display the alarms. ILOG TGO also allows the network to be edited in real time. Here, we have a graphical palette with a variety of network elements. We can add a network element to this site by dragging and dropping it into place. Once positioned, we can give it a name and link it to the network. ILOG components are available in C++ and Java, which permits the visualization of the clients through a web browser. All the applications are available through the Internet. ILOG Server has made possible the synchronization of all the distributed interfaces when an alarm occurs in the model. ILOG Server is also the component that enables the transparent distribution of our interfaces through the IONA Orbix communications layer and the Internet, as it is tightly integrated with IONA Orbix Broker. At the alarm level, if an event is simulated on a map, we can see that it's reflected on the Java client application. This synchronization of the different client applications is done selectively in real time. Each client application only receives the information relevant to it. This is accomplished by using ILOG server to synchronize our distributed graphical interfaces. Together with distributed visualization functions, one of the most important functions of a network management system is to reduce the vast number of alarms coming in from its networks. ILOG rules can filter and correlate data from a wide variety of events. Here, we pop up the editor and construct a filtering rule with an intuitive scripting language. Each rule contains a set of conditions with a set of actions. When all the conditions are satisfied, the actions are executed. ILOG rules enables powerful filtering at the equipment level, eliminating redundant alarms. For example, with this multiplexer, we have an alarm on the output, and with the demultiplexer, an alarm on the input. These two alarms are redundant and therefore eliminated. The alarms are shown in gray on the alarm panel. One of the most important features of ILOG rules is its ability to introduce new rules without stopping the application. Here, with the graphical ILOG rules builder, we are going to insert a new rule into the agent by simply using the mouse. We're going to define a temporal rule to filter upstream alarms. Here, we will state that if there is an alarm with the severity level warning, the agent will wait 5 seconds before acting. During that time, if the agent receives an alarm more severe than warning, it will only keep the second alarm. If no alarm greater than warning is received, then the agent will only confirm the first one. The message will then be increasing alarm. With the rule builder, we can check whether the rule is correct, and we can also insert the rule into the system. In order to trigger the alarm, let's place a warning alarm on this equipment. We will now wait 5 seconds. Here, we see that the warning alarm has been confirmed, since no alarm with greater severity was received during the elapsed time. Now, by creating a second alarm and inserting a greater status into the 5-second time frame, we see that the rule has triggered the action for showing our special increasing alarm message. The web has changed the way people used to think about client-server applications. As we have seen in the demonstration, ILOG and Iona Technologies have teamed up to provide the software components that make such connectivity possible. With Java, the applications can now link clients to servers through the vastness of the Internet. We are now making network management via the World Wide Web a reality.